Now it is my privilege to introduce our esteemed panelists for today, Naryn Davar-Timbre, and he's a partner and the Director of Business Development at Passive Design Solutions, Canada's most experienced passive design firm. Also with us today is Sprout Dwelling Zone Director of Product Development, Patrick Spelliscy. And with that, I'll hand it over to Patrick.
Awesome. Thank you, Sean. So this is our second webinar in a series of 4 that we've been working on. As Sean mentioned, they'll all be available on our website. And today we're talking about energy efficient building. I'd also like to thank Naryn for being with us today. Passive Design Solutions is at the forefront of building net zero homes in Canada. And during the lead up to this webinar and chatting with Naryn, I've been reminded of the importance of sustainable buildings. And for everyone, I'm excited to look at the next steps that Sprout will be taking to provide net zero energy ready homes to our clients. So thank you to Naryn and Passive Design Solutions for leading the way in energy efficient buildings. And I couldn't think of a better person to have with us today to discuss the topic. So thank you, Naryn. Our first slide, Sean, if you don't mind going to that one. Efficiency Canada has set a goal that all new buildings will be built to a net zero energy ready standard by 2030. I wanted to start off today by explaining what net zero energy and net zero energy ready buildings actually are. So net zero energy buildings can produce as much clean energy as it consumes. It uses on-site or near-site renewable energy systems to produce the remaining energy that it needs. Now, a net zero ready building is designed and modeled to the same standard as the net zero energy, but it doesn't yet have that on-site or off-site renewable energy components in place. So today we have several slides that explain the features of a home that make it energy efficient. We'll talk about 3 main categories of holistic design approach to building and optimizing efficiency, the specifics of building envelopes that when designing to be net zero ready, and the mechanical systems that will ultimately leverage the energy efficient design that we talk about. So before we dive in, I'd like to ask you, Naryn, leading up to this 2030 goal of net zero energy ready buildings, why is it important that we're talking about it now?
I think one of the ways in which, first, thanks for having me, Patrick. Really appreciate the opportunity, and Sean, always to talk about energy efficient building. But I think, an easy way of explaining it to folks is that the building code tends to be the caboose on the train, right? It's kind of bringing up the rear and enforcing a minimum standard, typically around safety, but more and more we're looking at things like energy and hoping that we can bring that minimum bar up, partly because I think there's a moral imperative around climate change and our contributions to it, but we also live in a winter climate where it makes sense to do a lot of these things that are now standard practice in energy efficient and net zero construction. So I think we have the opportunity to move up train in that analogy and really start to look forward to some of these standards being implemented and say, if they make sense in 2030, which is 5 years from now, doesn't it make sense to start doing them now and to figure them out in a way that removes some of the obstacles that are inevitably going to come along, whether it's at a trades level, a design level, or at the homeowner level in terms of the cost and complexity of doing something that is ahead of what a kind of minimum document has laid out. So when we look at net zero housing, we think we can do that today pretty easily. Our company's worked on more than 400 passive house and net zero projects to date. So I think that the knowledge is there. We can really start to move towards these goals, and the sooner we do so, the sooner we start to enjoy the benefits, whether that's at a homeowner level, which is durability, comfort, ease of maintenance of a home, brighter, healthier spaces. Those are all really good positive paybacks, lower power bills, but also the sustainability piece, reducing the burden on fossil fuels at a grid scale, reducing the demand that homes put on the grid by moving to more energy efficient homes and shifting away from heating and cooling loads. So all of that allows us to look forward to what is going to be enforced as a minimum standard in the future and think about, moving there in advance of being forced to and doing it in a way that we have control and intention. And I think that makes a lot of sense to people, whether it's in the profession or on the homeowner side of things or developer.
Yeah, absolutely. I think premeditating and thinking about how we're going to be designing homes in our future in anticipation for this is very important, and kind of getting the support and excitement behind it early is really great. So we'll dive right in and we'll talk first about design and the holistic approach to designing an energy efficient home, um, which means that we're looking at all the factors that will passively help a building perform as best as possible. So, these include things as, orienting and sizing windows to create solar heat gains in the winter, creating overhangs in key areas that limit the amount of overheating that can occur in the warmer parts of the year, considering the geometry and layout of a building to be spatially efficient, as well as limiting its exterior surface area for heat loss, importantly, allowing for the appropriate structure, space, and hooking up for sustainable energy development through rooftop solar voltaics, creating well-sealed and insulated building envelope, which we will be moving into as a whole section right after this. And very importantly, checking these design decisions using energy modeling and seeing which of these designed levers that we're using can be adjusted to create the best possible building. So the images you see on this page are net zero and net zero energy ready. I believe a combination of both are all projects from Passive Design Solutions. So Naryn, would you be able to talk a little bit about how the holistic design process has helped you design these homes, and maybe some of the aspects that help contribute to making them actual net zero homes?
Yeah, sure. I think the holistic approach is really crucial. So, our team does the energy modeling in-house as part of the design process, and we offer, stock pre-designed passive homes, net zero homes, similar to the kind of product approach to housing that Sprout offers with accessory dwellings and some pre-designed models that are available. We also do custom architectural design. And in either case, we really want to bring all of those things you mentioned to the design and think about it, like you said, holistically. We can focus on passive solar heating when we think about orientation, but we're finding increasingly that cooling and reducing cooling loads and overheating potential is something we really need to worry about. We're having more long, prolonged summers and heat events that are driving discomfort at a rate that you need to plan for, particularly around west-facing glazing. So it's not just thinking about how do we get some free heat from the sun. Passive solar is part of it. Passive house, making a more efficient building design that's compact with a good building envelope, obviously also part of it and really compatible with passive solar from a holistic perspective. But increasingly, we're also including things like best practices for wildfire prevention and to have soffit protection and non-combustible siding if you're in an area that could be, even if not historically, a forest fire risk area, somewhere where we're seeing increasing risk now. So people are more aware of that stuff. And I think there's an opportunity for it to all lean in. And we also look at aging in place as part of that. So how can you use the exposed thermal mass of a slab on grade foundation that's been super insulated to also provide really good long-term accessibility to homeowners, right? You can kind of make 1 + 1 = more than 2. If you think about things from the start and really, put all of those ingredients in when you're doing design. Energy modeling especially can be used almost as kind of pastiche at the end, right? We're just going to do an energy model to see what the actual sizing of the system needs to be, not to use it as a design tool to ask what systems are appropriate, what are the loads, what changes can we make at a building envelope or a geometry level that impact things downstream, like the mechanical system sizing. And can we get some real data about that and move past the kind of rule of thumb approach to design?
Yeah, and it's a really good way to look at how what you're doing to alter all of these changes are and how it's going to affect the project. And I think you also made a really good point there too, is, we're not all, like for Sprout especially too, we're not just looking at just the energy components of buildings. It is that aspect of aging in place or transitional housing, or even like you mentioned, forest fires. A lot more comes into this than just, trying to make a home super efficient. There are social and, climactic impacts that we're, trying to look at and see as far ahead as possible to really create some nice holistic homes that are going to last as long as possible. Because, at the end of the day, the longer your home can last and provide shelter, the more you're going to see that benefit over time.
That's right. We see it as a bit of a constellation, really, of all of these different contextual factors that drive the design process. We were talking, in preparation for this about how the ideal geometry for a passive house is a sphere. So, go get yourself an old gas storage tank and, make a house out of it. But spheres are kind of hard to inhabit. A lot of furniture is angular, rectilinear, right? So there are kind of compromises all the way along. But what we look to do is get some real data and not make assumptions, because I think a lot of the early energy efficient housing that was kind of, rule of thumb, squint your eyes at it, you ended up with overheating that was unintended, or overnight losses because of the massive glazed areas that were unintended. And those are things that we can quantify. And I think as designers have increasingly a responsibility to check in with, and say, hey, we can take the data and actually drive the decision making from the data, rather than the trial and error process, where individual homes become the prototypes for what you're doing. The model, in a way, becomes the prototype for the next build.
Yeah, and we have on screen now a couple of Sprout projects. One is a rendering of a project that's currently under construction, and one that has been built that has leveraged some solar for providing energy to the home. But like you mentioned, we have been at Sprout trying to create a system and using rules of thumb, and also doing some energy tests to see kind of where we stand. And I think going into this next phase of leveraging some energy modeling and looking at some of the important changes that we can make to really optimize the system that we've got going for us is going to ultimately help clients and stuff in the future to really have these really nice, well-built homes that perform very well for them. So yeah, it's very
Absolutely. I mean,
exciting.
it's kind of what we were talking about before of energy efficient housing having a bit of a spectrum to it, with, code minimums being on one side, and maybe certified net zero passive home, all the way on the other side. And in between are things like the pretty good house, better than code. And often you can get there with best practices to a certain degree. And then, you really need an energy model to be able to move beyond.
Yeah, and I think that's a good segue into our next slide there, Sean, for the building envelope, because the building envelope is a very important aspect. And for those who might not be familiar, when we're discussing the envelope of a building, we're referring to its components that are the barriers between the inside environment and the outside environment. So this is our foundation, floor system, exterior walls, and the roof. So, many of you will know and understand the importance of properly insulating a home as a key part of mitigating energy loss. But it doesn't just stop there. There are many aspects of a home envelope that go beyond just the quantity of insulation. So, I'd ask Naryn if you don't mind elaborating on some of these other aspects, such as, eliminating thermal bridges, the importance of air tightness, and maybe some of the other qualities of a high performance building envelope.
Yeah, for sure. I think it relates very strongly to the passive house approach, in terms of how we treat the building envelope. So when you think about passive homes, they tend to be super insulated structures that have very few thermal bridges, which are kind of highways for heat to flow through the solid material of the wall or roof. So there's been extra work done at the details to do that. And then the air tightness, is really how much air is ambiently leaking through the building envelope. And again, either through manually sealing, or some of the more automated products that are out there that you can use to seal a building, care has been taken to really tighten up the building envelope so that you're controlling ventilation using ventilation appliances like an HRV or an ERV. And that air leakage accounts for a significant amount of the heating and cooling that you have to do to maintain comfort year-round in a home. So the building envelope is kind of the first place to act to begin to increase the energy performance. Moving to things like triple pane windows are fairly easy and established ways of increasing the performance of individual components in the assembly, and give people an option to upgrade, from a double pane or even a double hung configuration, which have very poor seals between the units, to a casement or tilt and turn or awning style operator, which just tend to have better air tightness overall. You know, these are decisions that we can make on the design side to make sure that we're getting to an envelope performance that reduces the energy footprint of the building such that we can fit the solar panels on the roof to get to net zero. So that's kind of the tie-in there, that if you don't do anything at the building envelope and you just build to code, you end up needing more solar panels than you can fit on site if you're ever going to achieve that net zero on-site energy.
Yeah, and I think it was an important concept that you kind of brought up as well is, you know, there's kind of the road to net zero has many avenues, and it's kind of coming out here now as you explain it, you know, there is building a code building that is kind of the code minimum. The amount of renewable energy you need to produce in order to, you know, make that a very habitable environment is so high, whereas you're really dramatically reducing that aspect when you get into this really high efficiency envelope. The demand of energy needed to heat that place goes down. It's all of these aspects really play into the part of that. And like you said, there is that kind of spectrum of getting to that net zero. And a lot of these passive house principles do a lot to really push you there.
Exactly. And historically, you know, the primary use of energy in the home is heating and cooling. So that's the biggest use of energy that you can act on by improving the building efficiency at the envelope. There is also a diminishing return. So it is something that drives a lot of decision making. You know, what is the return on investment? Adding insulation up to a certain point makes quite a big difference in the energy performance of the home because it reduces the heating by reducing heat loss through the envelope. Once you've super insulated and thermally isolated the building, you end up with a point where putting more insulation on doesn't really save you a lot more on your power bill because you still need to cook and have a shower and keep the lights on, and you know the envelope isn't really touching that. So we often try to find the tipping point where it's actually cheaper to put solar panels on the roof towards your net zero goal than to continue to upgrade the building envelope. So that kind of we've done enough, but we don't need to do more point is only really something you can determine again with an energy model, but it does dictate what you do with the building envelope, for example.
Absolutely. Well, I think we can move into our next slide there, Sean, specifically around, or we have some examples here, actually. I don't know. We're happy to talk to them, but and again, this will all be available on the website to look over again, but these are some examples from passive design solutions that are some really nice assemblies that describe a well-constructed envelope that really help achieve these. So if you wanted to maybe take a quick second and just describe a couple of those important aspects that do eliminate some of that thermal bridging and does provide a certain amount of insulation that kind of are put towards creating this envelope.
Yeah, so we've worked with a number of different assemblies over the years, depending on the projects and the clients and the builders that we're working with. Often it's some form of a double wall with a air vapor controlling layer in the middle of the assembly, which allows us to service the inner of the double wall while relying on the outer, typically for insulation and structure. So that could be an ICF with a service wall inside. It could be a double stud wall like we're showing here. It could be something like an outrigger, like a TJI or Larson truss wall. The advantage of the one that we're looking at right now is it's very straightforward for any builder who's building 2x6 stick frame construction to take on and to achieve really good air tightness and thermal isolation between the walls. And it just follows the normal sequence of trades. We're showing attic insulation that would be blown in cellulose and a foundation that is an engineered super insulated but shallow foundation, a structural slab. Those are interesting to note because of the last point on the previous slide, which was around embodied carbon. So there is always a trade-off between cost and embodied carbon. I think increasingly, as we move towards net zero energy, there's going to be a conversation about net zero carbon. And net zero carbon is actually the more important one from a sustainability and climate change factor, because if we emit a lot of carbon building net zero homes, we actually have to pay the climate change cost of that carbon while we're in those energy efficient homes. So if we can reduce the carbon to get to net zero, we're actually doing both things at once. And so, when we use less concrete, when we use carbon-based insulating materials, that's part of it. but those aren't always widely available. For example, carbon-based bat insulation. So you'll see, the pink stuff shown here because it is widely available. And we do work with clients, basically coast to coast to coast in Canada. So on Newfoundland looks very different than in Nova Scotia or Central Ontario or, coastal BC or up north. And you do need to be adaptable in order to achieve these targets across such a geographic region as Canada or, range of climates.
Yeah, absolutely. Absolutely. So we have our super insulated envelope. We have our, if we remove and all these great aspects that we've designed into creating this great building that can perform very well. If we're moving into mechanical systems now on our next slide, um, I'd kind of like to start this off because when we talked about it leading up to it, Naryn, you described it very well. How are we now taking this really efficient building and leveraging that to decide what the mechanical system is going to be? And maybe describe a bit about what an electric-based mechanical system is composed of that leverages all of these design aspects.
Sure. Yeah. Most of the homes that we're designing that are net zero are grid tied. So the idea is that you're buying all of the power you use from the grid and you're sending all of the power that you're generating with your rooftop solar to the grid and being credited for it. So there's a net metering going on at the home. That's very different than, say, off grid, where you're kind of an island unto yourself from an energy perspective. So the majority of homes are grid tied and net zero. And so it makes sense then to use all electric appliances for heating, cooling, hot water, everything, if you can, because you can then generate that power on the roof. If you use propane or wood or any other fuel source or energy source, you're basically always paying that energy cost because you're not able to offset it with renewable that you're generating on the roof, and you'll never get paid out for the positive credit on your account. You can't turn your house into a solar farm, but you can net zero over the course of the year, right? So the idea is we reduce the heating and cooling requirements significantly and then use very efficient electric appliances like heat pumps wherever possible, and very minimal systems wherever possible. And that allows you to put in fewer solar panels to achieve that total net zero designation. So we're often using things like ductless mini splits to heat the homes that we design. We're often using electric baseboards for backup, which are not required for comfort because the homes maintain temperature quite easily. And then using a high efficiency heat recovery ventilator and a heat pump hot water heater just keeps the operating costs very low and the system's quite minimal. So people will come in and say, I'd like warm floors, so I want in-floor radiant, but then I want AC, so I'm going to do, a ducted heat pump. And then, I really like the ambiance of fire, so I'm going to do a propane or wood stove in the corner. And when you look at the mechanical system cost of that versus a ductless mini split and some electric baseboards, it's very, very different. And what we try to help people do is to understand they can still achieve comfort by investing in the envelope and then putting in a smaller, more minimal mechanical system, which is easier to operate, maintain, and leans into that aging in place as well. There's just less for you to have to deal with, less redundancy in the system. And the passive house side of it gives you more certainty that if you have a power outage, if you have, a winter storm that you have to shelter through, your home isn't at risk of pipes freezing or, vulnerable in the same way that traditionally houses have been.
Yeah, absolutely. It's interesting to see the amount you're able to provide power, everything you need for your home in such a low quantity when things are really built up in this way. So, and I mean that includes one question I did have for you before this too was and I got it the other day as well is heat recovery ventilators, which are a very important aspect, and energy recovery ventilators. I know people had a specific question about that, and as did I when we talked about it. But the difference between a heat recovery ventilator and energy recovery ventilator, would you mind just describing the difference a little bit and why it's probably more important to have heat recovery ventilators more in our climate than an energy recovery ventilator?
Yeah, the HRV ERV question comes up a lot, and it is really climate specific. And I think what it comes down to is the ERV doing humidity exchange, whereas the HRV is just doing heat exchange. And because there is exchange of humidity, that can cause moisture transfer at times of the year that are inconvenient for maintaining the interior comfort parameters and durability of the home. And so in some climates where the loss of humidity, especially over a dry winter, can be countered by having some of that captured coming back in, it can be a really effective appliance. In really wet climates year round, like we have, we find we use HRV and ventilation to actually dry the home out using ventilation, bringing fresh air in. And that can be an effective strategy also to keeping the homes at comfort parameters. So it is really a climate based decision, whether we use an HRV or ERV. And in Nova Scotia, primarily, we do use HRVs.
Yeah, definitely. And thinking of places that well, I'm from Edmonton or from Alberta, there tends to be long, dry winters, and here in Nova Scotia, the complete opposite. So just like Canada is a very interesting example because there are so many climate zones, there are so many different places that have different insulating requirements. So thinking about these, in a very context-specific way is important. So not every solution is going to be perfect for every home in Canada, but understanding the concepts and everything behind them and using the right systems is going to be very important for this.
Yeah, it can be customized and looked at with an energy model, right? Again, so that we can kind of have some insight into that. And I see that the question here about backup heating, which is a good one. It's one that comes up a lot. The simplest way that we meet that is to have electric baseboards in all of the rooms that would require heating. Our clients typically tell us that they set them to 10 or 12 degrees Celsius and they never turn on. But they are there and they have no moving parts and they don't require any maintenance. So it's a really good fail-safe for people to have, say if the heat pump did stop working. Many insurance companies now will allow a second heat pump to be the backup heat source in a home. So if you have two separate compressors and two interior heads, I know that people are having some insurers okay with that as a redundant heat source. And many homeowners will put one ductless mini split in the great room and one in the primary bedroom so that they have some zone control primarily for cooling. Heating is more easy to circulate through the home using the HRV and a ceiling fan. But cooling, it can be nice to have some zone control in terms of where you do that. So you may be able to get away without the electric baseboards. They're very inexpensive and they're all electric and they don't require any maintenance. So we find it's a very easy way to meet that requirement.
Yeah, and that's what we utilize here at Sprout for our backup heat as well. So it's a simple and easy solution that really does provide that backup for you. And talking about mechanical systems and its impact, our next slide, we have an example of a code built versus passive house, and it kind of a diagram that explains how the approach to this or how we kind of wrap our head around the approach to this. So, this is from Passive Design Solutions that basically explains, what a heating demand looks like in a code-built home and in a passive house or building that utilizes passive house principles, how it's minimizing at the end how much energy loss you do have so that the input is so much less that you're able to provide all the energy need for your home with a renewable source like sort of solar voltaics. I don't know if there's anything else more intricate in the diagram that you want to explain, Naryn, but I found it to be very helpful when it shows basically the concept of what we're talking about.
Yeah, I mean, on the left, you have your inputs. So I think it's useful to think about, solar gains, mechanical heating, and internal gains, things like cooking, turning on a plasma screen, puts heat inside the house. So those are the three inputs. On the right-hand side, you have the outputs, which would be envelope losses, window and door losses, passive ventilation losses, and active ventilation losses. So you can see in the code-built version, you're primarily losing energy through the envelope and having to make up for that with a very large mechanical heating load, like you said. So the idea is in the passive house, the solar gain and internal gains are the same or very similar. But because the heating load is so much smaller, it's balanced on the right-hand side by those envelope upgrades, that you have less passive ventilation through that airtight envelope, you have less heat loss through those inefficient windows and assemblies and doors, given that you've super insulated and eliminated thermal bridges. So that's really, these diagrams come from a custom home that we did design that was built in PEI. And so that is part of the energy modeling that we're looking at, is what can we do to reduce that heating load, again, because it informs the envelope decisions and the sizing of the mechanical system.
Yeah, and if you can go to the next slide there, Sean. The This is kind of the concept we're, kind of really working towards, is, passive design making net zero possible. So, again, by really reducing that heat loss, you're providing the opportunity for it to all be more, I guess, all of the energy requirements being on site. And this diagram representing the importance of the ventilation system that is helping circulate and recover a lot of that heat and energy from the building itself as well. I don't know if we actually dove into, I'm sure some people here will be very familiar with HRVs and ventilation systems with heat recovery, but it is kind of a cornerstone piece of a project like this, is really trying to recover heat that is in your home as you're venting and exhausting it to the outside and bringing fresh air in. I don't know if there's too much more you want to add to that, Naryn, but
well, it's interesting because it's a code minimum requirement in Canada. So every home being built does have an HRV, but we do a lot of work with clients in the US as well. And many states do not have minimum code requirements for an HRV to be in a home. And so what's interesting is when you look at the upgrade cost to Passive House, if the code minimum is further behind, it becomes more onerous to get to the same energy standard. So for a lot of folks who are looking at the code minimum and saying, I don't need an HRV, I don't need to provide extra insulation, I don't need to provide triple pane windows or any of these things that you're talking about. So the leap to getting to that level of energy performance is actually bigger than when you're starting with more rigorous codes. For example, the BC step code, if you're looking at step 4 or 5, you're really looking at Passive House energy efficiency levels from a code perspective. But when we're looking at other jurisdictions, I think that's where the conversation about 2030 and planning ahead, and also hoping that we do bring those code minimums up sooner than later. A lot of people who end up in housing don't have control over what that housing is. So, we often think about single family homeowners driving it, but a lot of homes are built by developers or by one person and then sold to another, or are occupied by renters. And so I think as the building standards increase, everybody does benefit from, what we know these paybacks are for investing in building better homes.
Yeah, and I think that's actually a really important aspect of what we're talking about today, is that, having the code change and working towards this is going to benefit everybody, because not everybody at every time has the opportunity to purchase or build or own a house. They are renting, or it is transitioning to other parts of your family. So, including these as parts of the code and making this, this is, we're treating it as importantly as it is, as we are, is definitely going to provide nice homes and climate, or for everybody who has to live in them, as well as, for the environment. So yeah, that's great. Our final slide, Sean, it kind of is a big wrap on features of a net zero home. So, I won't go through every little aspect of this, but it kind of is a nice diagram that tidies up and shows all the aspects and elements of net zero home, and what you're looking at, what we're looking at trying to do for clients and for people we design homes for, to attain this net zero home. So everything from, the efficient water management, appliances and lighting that require low amounts of energy, renewable generation, and then especially, heat recovery, and again, that air sealing and proper building envelope, that are all going to contribute to this net zero home that we're working towards. So yeah, that is our last slide. I don't know if there's anything else you wanted to mention there before we open it up to questions, but we're happy to answer questions. And again, if anybody has something that they think about later on today or later on, feel free to get in touch with us because we're happy to chime in and discuss anything that people might be looking for information on.
Yeah, I think, the only thing really to emphasize here is the reciprocity between the design of the home and the decisions that are made and that path to net zero. So, you could build to code and need 50 or 60 solar panels that won't even fit on the roof, or you can build a home that is at a higher level of performance with a lot of these components thought through and selected, and you end up with a solar array that actually fits the roof of the home and can get you all the way to net zero.
Great, great. Okay, awesome. Sean, I think, should we open things up for questions now? I see there's a couple in here.
Yeah, the mounting of the ductless mini split heads, people often don't want them low down. Just to respond to that one right away. We
Yeah.
often do put them up a little bit kind of above door, or in a less intrusive location where they're not going to blow on anybody actively while they're seated at the living room or dining room table. And then we use a ceiling fan typically to get good circulation. So a ceiling fan is a really important part of the mechanical system, actually. You can get quite a lot of stratification, and most people, when you get a nice big living, dining, kitchen, want the cathedral ceiling space as well. So once you get that vertical height, you do get the temperature stratification, and having a ceiling fan to distribute that along with the HRV, which is extracting from the kitchen, bathroom, laundry, and supplying to the bedrooms, and living room spaces, then you get really good heat mixing in the home.
Yeah, and we've been finding that too with Sprout. Our models, we do the cathedral ceilings, which are tall volume of spaces, but they are very apt to having the heat rise. So
Up to the top.
yeah, ceiling fans have actually been a very, I was surprised, but also obviously it makes a lot of sense of how important those are to really distribute that heating appropriately. Great. We have a question here too. Can you
I'm
expand
going to
on?
interrupt real quick.
Oh, sure, no problem.
Sorry. That we just had a few other questions that came in before the event and on the side. So I just wanted to kind of attack these in order. Leah had reached out early, wanted to know how our Sprout buildings, at least the Sprout building design, compares to passive house design. And I think there's some key differences, but wanted to have you both speak to that for a moment.
Yeah, sure. So for Sprout, we currently are using passive house concepts and principles to provide certain ways in which we bolster the envelope of our building. So we're doing those super insulated slabs, providing a higher than code level of insulation and detailing. We're making sure that we have a thermally separated envelope, meaning that the insulation on the exterior of the building is completely covering the structure to minimize a lot of those gaps where heat loss can penetrate through the building. And we've made all of our buildings solar ready and have one of them that has been equipped with solar panels. So we are using these passive house principles to work towards a very efficient building, but we don't currently build a passive house certified Sprout. I think we're on our way to working towards having really high efficiency sprouts, but as we work towards that, we're always committed to trying to do as much as we can to work with those principles and getting towards that net zero level.
Yeah, and I'd add to that just for my familiarity, if we haven't made it clear that the slabs are insulated, we leverage a locally designed and manufactured product called Fast Slab for an insulated slab, which really sets the foundation for the rest of it. The air tightness, which I know is a key ingredient to all of this. We've done some tests with results that we're happy to share. I know Patrick maybe could speak to some test results as well.
Yeah, so the building that we had in the example earlier on, it was pull that one back up there, Sean. So yeah, there we are. So we had this one tested by HomeSol, and they test for, or they look at how much heat loss you have through your windows, through your walls, how airtight your building is, and in this case, the solar, how much you're providing. So in this context, we had not quite a passive house level of air transmission. It was 1.7 air changes per hour, which is in a good place, but not close enough yet to a passive house level. There are things we can do and processes that help with this air transmittance, but overall, the solar just on that one side of the building is providing 66% of the energy for that building. So, this was one of our earlier buildings in our effort to really design something that's going to push towards that net zero. And, taking a bunch of these concepts and things that we learned from these buildings, we keep pushing towards that net zero goal. So that's one of our buildings that we have a lot of good data on. And I think as we continue to build more of our buildings, we're really looking at all of those important aspects and passive house principles that will really give an edge and help produce that net zero product that we really want to provide to everyone.
Yeah, I think it goes back
Thanks.
to that spectrum, Sean, that we were talking about as well, like passive house certified. We do very few homes that are fully certified these days. People often opt for a net zero solar array rather than pursuing the additional time and cost of fully certified passive house. For us, there is a distinction on an energy modeled and a non-energy modeled building. So having a site-specific energy model is really important, I think, to move, like you say, to that passive house end of the spectrum. But we do a lot of uncertified passive homes that do achieve the 0.6 air changes per hour and are very close in terms of the annual targets set out by either FIAS or CAN-FI, both of whom we've certified with in the past. But I think increasingly people are looking at net zero.
Excellent. Next question. Is there anything to consider with regards to net zero for a garage add-on in terms of EV charging and some high energy use items like hot tub and sauna?
Yeah, hot tub and sauna are a tough one. Unless you're talking wood-fired, you're always going to be putting, probably an equivalent number of solar panels for just that as for a massive part of the rest of your power demand. So the high energy use appliances are, they are what they are. They have big plug draws and large demands, and they will be disproportionately large when you build an energy efficient home. Hot water is domestic hot water is kind of the next big energy demand after heating and cooling, and I'd imagine those appliances could be comparable. There are definitely alternatives, and a lot of our clients do use things like wood-fired saunas or wood-fired hot tubs. Living in a kind of rural setting that can be appropriate, maybe less so in an urban environment. And I'm forgetting the other part of the question there, Sean, if you could.
It was in.
Oh, garages, yeah.
EV charging, yeah.
I usually tell people to plan for an unheated garage. That's the biggest factor. Those big overhead doors are very leaky. So if we're looking at a heat pump that puts out a very small amount of heat constantly to maintain temperature, when you have a building like a garage that can have a huge amount of heat loss through something like the overhead door, then the heat pump can really struggle to keep up with it. And when you have spaces that are drywalled, that you're bringing vehicles into that are heated, and then the snow melts off and the humidity spikes, there can be a cycling of humidity that leads to mold and mildew that's very difficult to prevent just because you're operating it in a very extreme way compared to, say, a home where most of that bulk water stays outside.
Very good. Can you expand on some of the differences between air-to-air, air-to-water, and GSHP heating differences, and when you would choose one over the other?
Yeah, there was a lot of experimentation over the years with in-floor radiant or radiant fixtures, or air to glycol, air to water, heat pumps. And my approach when I work with clients, I think our company's approach is to usually recommend air-to-air ductless mini splits or air-to-air heat pumps in general for heating and cooling in the home, and heat pump hot water heaters. They are fairly simple, easy to maintain discreetly. You can do maintenance or replacement on the head or the exterior compressor independently for the ductless mini splits. And they heat, cool, and dehumidify. So when you build a passive home or a near passive house performing home, the heating and cooling loads are so small that a single ductless mini split can often supply all of the comfort, for the year, whether that's heating, cooling, or dehumidifying. When you put an in-floor system in, what you're doing is installing a heat-only system. So we still have humidity and we still have cooling as comfort parameters to deal with throughout the year, which means you're probably going to add another system to tackle those things. If that other system is a heat pump, it could just do your heating as well. And I know someone had a question about in-floor heating versus unheated, which is kind of related. And so we super insulate our floors. Code minimum is R10, I think, a couple of inches under slab. Many of our slab on grade projects have 10 inches of foam insulation under the slab. So, and that's continuous all the way around with no thermal bridging. And that really does isolate the floor so it's cool in the summer, warm in the winter, without active heat being in it. It can act as thermal mass in the energy balance, so it heats up during the day and can buffer heat loss over the night cycle, and maintain interior temperatures. So that's a really beneficial way of approaching the slab, rather than embedding active systems in it that then need recirculating tanks, extra mechanical room space, extra maintenance, and still don't address humidity and cooling.
Yeah, and I'd like to add to that too with the super insulated slab. We have had clients and other people look at doing these in-floor heating systems and really, like Naryn mentioned, creating this big thermal mass and having it provide that. We've heard, and I'm sure you've heard too, Naryn, from using the same product, that it's a very comfortable floor. And I get that heating is kind of a nice ambient feeling and stuff, but there are instances and occasions where it does feel warm to the touch and there isn't this kind of big heat loss. It is very comfortable. And so it kind of, I think the gains of using a system like that and super insulating definitely far outweigh, at least in my opinion, the needing to run all these services and mechanical in this actual slab, which, yeah, it does get complicated, can lead to some energy waste.
Yeah, and I think people think, oh, I'll have in-floor heat, I'll have warm floors. But really what you do is you set it to room temperature. If you do heat it up, suddenly you're recirculating warm water through the slab for hours and hours after you've already achieved the interior air temperature you're after. You continue to heat the home. So there's an overshoot with in-floor heating if you do turn it up to the point where you're feeling warm floors. People think of it more like the electric in-floor radiant that goes in under tile beds, where you can actually feel the warmth in the floor because you've turned on the heat there. But with these recirculating ones, it's really about maintaining an interior temperature that's around room temperature. So you don't even really feel them as warm. But the installation tends to be very expensive. The maintenance would require a jackhammer, and it still doesn't address cooling or dehumidification.
And just to round out Derek's question, who brought that up in the first place, yes, we found that to be quite successful through the winter. And I know our sprouts are leveraging the same system that we were speaking about. We achieve an R value of 30 on our floors for our slab. And we do have customers that comment, that they've had people over say, "Oh, I love your in-floor heat." And it's not actively heated. It's simply, well insulated and warm, maybe not actively warm, but not cold on the foot.
Exactly.
Yeah.
Moving on, Danny would like to know, what are some key elements of a fire-resistant design, other than, say, the type of fire-resistant siding? Some of the photos in the presentation showed little or no overhangs. Is that an element?
Overhangs can be part of it. There's some pretty good best practices guides that have come out in Canada, and the one in particular that we have referenced is escaping me right now, but I can follow up with Sean and Patrick and send it over. But it does include things like non-combustible materials. It does include thinking about the building assembly. So people often think, oh, I'll build with ICF because it'll be fireproof, but there's 2 inches of foam that's integral to the building assembly on the outside of that concrete. The 2x6, 2x4 double stud wall that we showed has plywood on the outside. and could have metal siding, which would be quite durable from a fire resistance perspective. Soffit protection is another one. So a lot of fire spread happens, and in the LA fires, this was true as well, where the trees are unburned, but hot drafting air full of sparks, draws flames up into the attic insulation, and suddenly you have stack effect and a roof fire happening, burning buildings out while they're surrounded with green vegetation. So that soffit protection is really important. Someone just put in landscaping. Landscaping is not something that we typically are involved in, but definitely has an impact. The materials of the building, we have more control over the assembly, the detailing of them. So those are primarily the things that we focus on to limit fire spread. But if somebody was in a active fire risk region, we might delve even more deeply into some of those best practices.
Mhm. Yeah, because they're, and by code as well, I mean, mostly in more built up areas, there are requirements of when your structure needs to be, like when your cladding needs to be non-combustible, but also when your structure needs to be non-combustible. And yeah, like Naryn said, in some of those cases where you are in areas more prone to fire or something, there are, solutions for, providing the best possible envelope for that specific scenario.
All right, thanks, guys. Is it possible to install a central ducted heat pump in a structure without a basement?
Absolutely.
Yes. Yes.
You've got to plan for bulkhead, because that's what's going to come back and bite you. If you do an 8-foot wall height, you're going to have an 18-inch bulkhead running through that people are going to bonk their heads on. So you have to plan for it, but it is possible.
Yeah.
Another question. Please comment. Installing a thermal bridge in an existing home is not practical, correct?
I'm assuming that would mean eliminating a thermal bridge or installing a detail to eliminate a thermal bridge.
Yeah, and I would assume the latter.
So renos are really tricky for thermal bridging because the components often are already in place. Your best bet is to go over the outside of the entire building and add kind of outsolation. The Recover Institute here in Halifax kind of led an initiative around that and is now looking at deep energy retrofits from that perspective. So doing like an over panel that would cover your joist space from the outside, your walls from the outside, your roof rafters from the outside, and really eliminate all of that thermal bridging by wrapping the entire house as best you can. But you're still going to miss the slab if it's an older slab. You're still going to miss the concrete walls if you're not excavating below grade. So, it's difficult to do the same holistic approach. Air sealing is equally difficult in a reno perspective, but you do have the advantage of some products like AeroBarrier, which is an aerosolized acrylic sealant. So you actually pressurize the house with a blower door and then push that sealant everywhere. And that's a great way of approaching a reno, but it does ruin horizontal surfaces. So again, kind of deep energy retrofit being the more practical application of that, or new construction. But it is difficult to do similar with reno or retrofit than you can with new construction where you have full control.
Excellent. That question came from Eric, and he's elaborated on the side here. He might jump on to ask, but he elaborated. Oh, he's unmuted, so I'll hand it over to Eric.
Hi, everybody. I appreciate this presentation. It's terrific. Yeah, I wish when they built my home, which is electrically heated primarily, they had gone 2x6 construction, but they did 2x4. I looked into sheathing the outside in a styrofoam and having the house re-sided. The flashing and all of the covering for the windows it really got expensive, and I was dismayed by that because I knew that would be the fastest, easiest way to thermally break what I have in my current home. But, I know it's a balancing act. I was just exploring the idea.
Absolutely. It's really tricky, and there's a bit of logistical planning. Maybe you say, okay, I can afford to do the windows and switch them to triple pane this year, but then next year I can do the foam. But now do my new windows match up with the new depth of the wall and all of the trim and detailing there? So figuring out how to do it and not have it scale into a full deep energy retrofit is
Yeah.
difficult. And often just kind of replacing the windows and maybe putting some foam insulation
Mhm.
when you reside is the most common and often lowest hanging fruit. If you're vacating the home and protecting horizontal surfaces and then doing something like aero barrier to get to the air tightness can be great. But it is difficult to do things holistically, especially when the home is occupied.
Perfect. I appreciate your response. Thanks.
Thanks, Eric. I noticed that Kelly had just left, but she also had one little comment in there saying landscaping has a very large impact on fire spread as well. But it just made me think of another element of landscaping and its importance on solar gain. It can be leveraged as well, you know, in the summer with trees with leaves and everything. They provide shading and can often help with that overheating for light coming into the home, but also in the winter when they do lose their leaves. The sun is now allowed to shine through them, so they kind of act as a natural barrier. So it's just another way of thinking about, you know, it's not just a home. There is landscaping. There are elements around it as well that are important to consider when you are locating and placing stuff like that. So I just found that an interesting comment. I wanted to
Absolutely.
comment quickly.
And I think you can extend some of the thinking we've had today outward from the home. You know, landscaping is often done after occupancy. So, you know, you might not
Yeah.
work with the original designer of the home. You might have some kind of ideas and then you get moved in and you actually do some fine grained landscaping. But, you know, really thinking about that from a accessibility perspective and how you landscape, that's inside the home, but also outside the home. You know, thinking about fire spread and fire safety, that can be something that extends from the home out to the landscaping. Like you said, solar orientation and planning for deciduous and coniferous trees in the right places to help with energy. All of the stuff we're talking about with the house can really extend to the context for sure. And I think it's worth thinking through. But it is something that often gets resolved downstream when people are moved in and have the time and capacity to think about those things.
Yeah.
Excellent. Well, I think we've covered all the questions that were submitted, but if anything comes up after the fact, by all means, please reach out to us. We will document those and answer those to the best of our ability. As I mentioned, this seminar will be posted on our website. Give me a day or so. But yeah, thank you very much for everyone attending, and thank you very much to Naryn and Patrick for hosting.
Yeah, thanks
Thank
for
you, Sean, and thank you, Naryn.
Bye.
All right. Thank you. Take care, everybody.